In this video, we are going to discuss data science interview questions. What is data science? Data science combines domain expertise, programming skills, knowledge of mathematics and statistics to extract meaningful insights from the data. Data science practitioners apply machine learning to numbers, text, images, videos, audios and make the machine learn from the data. And once it is trained from the data that it is already provided with, it starts predicting on the new data. Once you go out for an interview for the role of a data scientist, then you can expect questions related to Python, statistics and machine learning. In this video, we will cover few Python basic interview questions, few statistics interview questions and one algorithm. First question is related to Python. This question is all about conditional statements. You have a variable and if that variable is having is in it, then you have to return the variable as such. Else you have to add an is in front of that variable and return it. Let's see how we can perform this in Python. First, I'm going to create a variable character and I'm going to assign value empty to it. Now I have to check whether is in this variable or not. How I can do that is by checking the condition or the variable. How I can check that is by using if statement. If is in character, what I have to do? I have to print the variable as such. Else I have to add an is in front of it and return the variable. So here I am writing another one condition. So this is not present in that variable character. So what I am doing here is I have added an is in front of that variable and return the output. Write a Python program to append values to an empty list using iteration. The steps are, first you have to create an empty list to get the values appended to it. Next you have to run a for loop with range function to create some auto generated values. Then you can use append method in list to append values to that empty list. Let's see how we can perform this in Python. First I am going to create an empty list. Then I'm going to run a for loop. For I in, I'm going to use range function. I'm going to pass values from 0 to 10. Next, what I'm going to do is a dot append I. I'm going to append each value of I to that a. Next, I'm going to print a. Now, if I run this, the a will be having values from 0 to 9. Reverse the below variable phrase. Phrase is having this dot is dot a dot string. You have to reverse it and the output should be string dot a dot is dot this. How we can do this is, first we have to split that variable by using split method based on the delimiter dot. Next we have to store that into a variable. Next we have to use join method with dot to reverse it and to add dot to it. Let's see how we can perform this in Python. First I'm going to create a variable for splitting. How I can do that is, just I'm going to create phrase and I'm going to assign a value. This is a string. First thing I have to do is I have to split this variable. So I'm assigning a variable name split and I'm going to use split method. Phrase dot split. I'm going to separate it based on dot. Next I'm going to print this. So this is separated. Next what I'm going to do is I'm going to do join and I'm going to reverse it. How I'm performing is I have to add a dot, then I'm going to use join, then on what? On this split method. Split of colon colon minus 1 will reverse my string. Then I'm going to add a dot in front of it and return it. So this is the required output. Here I have added this dot is dot yes. I'm just replacing it with a. So the value is changed now. This is the required output. Next, write a function to add all the values in a given list. First, we have to create a list with certain values. Then we have to add all that values in that list and store it in a separate variable. This is the task here. How we can perform this using function is, first you have to define the function, then you have to give a user defined name to it, then you start coding your Python codes. We can see how we can do this in Python. First, I have to use the function. For that, I have to use the keyword def. Then I have to give a user defined name. Here we are going to add all the values. So I'm going to give add as the user defined name for this function. Next, I'm going to create a variable in which we are going to save all the added values. Next, I'm going to run a for loop to get each values of that a. Then I'm going to add it to this count again. Count plus I. Then what should I return is return count. Now I have written a function. In this function, if I pass some values, it will give me the addition of all that values. I'm going to add 1, 2, 3, 4. So the output will be 4 plus 3 plus 2 plus 1, which is 10. So now I'm getting the desired output. Next, what is correlation and its types? Correlation is considered as the best technique for estimating the quantitative relationship between two variables. Correlation measures how strongly two variables are related. There are three types of correlation. One is positive correlation, second is negative correlation, and third is no correlation. Write a sample code to check the correlation between two variables. And how do you interpret the results? First, we have to import the necessary packages. Then we have to create two variables to pass that variables to our correlation function. Then we have to use Pearson R, which calculates the correlation between two variables. Let's see how we can perform this in Python. First, I'm going to import the necessary packages, which are randn from NumPy. From NumPy, I'm going to import randn. Next, from SciPy, I'm going to import Pearson R. Now that the required packages are imported, now I have to create data to pass to that Pearson R. So I'm creating random generated data by using ran function, and I'm naming it as data1 and data2. I've created one data. Next, I'm going to create another one variable data2, and I'm going to assign some random values to it. Now that the two data are created, I'm going to pass them to a Pearson R, and I'm going to store that to a variable called correlation. So here I'm going to call a Pearson R method. Pearson R, then I'm going to pass data1 and data2. Now that the correlation function is run, I'm going to print that values. As the output of this will be having many digits like a float value, so we are restricting the decimal points to only 2 decimal points. How we can do that is %f.2f. This restricts the decimal points to only 2. Now I'm going to print this correlation. See, the output is 0.98. First, once you get the output, you should know what that represents. The value of correlation ranges from -1 to 1. If the value is positive, it is a positive correlation. If the value is negative, it is a negative correlation. Here we have 0.98, which is positive. So it is a positive correlation. What is machine learning? What are the two major types of machine learning? Machine learning is the science of teaching machines how to learn by themselves. By passing a training data, the model learns from the data. Once new data is passed to it, it starts predicting on what it has already learned from. There are two major types of machine learning. One is supervised machine learning and another one is unsupervised machine learning. How does data cleaning play a vital role in the analysis? Cleaning data from multiple sources help to transform it into a format that analysts can work with. It helps in increasing the accuracy of the model in machine learning. It might take up to 80% of the time for just cleaning data, which makes it a critical part of the analysis task. What is linear regression? A linear regression is a good model for predictive analysis. For example, the price of a house depends on many factors such as its size or its location. In order to see the relationship between these variables, we need to build a linear regression model which predicts the best fit line between them and can help conclude whether or not these two factors have a positive or negative relationship. Let's see how we can perform linear regression in Python. Here, first I have imported the necessary packages. The packages are NumPy, Matplotlib, Cbond, Pandas, sklearn. NumPy, numerical Python. It's used for performing numerical calculations. Next, Matplotlib and Cbond are used for data visualization. Pandas is used for importing data, exporting data, and to do pre-processing activities in our data. Then I'm using train test split. It is used to split the data into train data and test data. Next, I have imported linear regression. Since we are going to perform linear regression, I have imported the package linear regression. So like this, which are all the necessary packages that you want? First, you have to import those packages depending on the algorithm you are working on. Then you can start working on it. Here I have imported the necessary packages. Now I have run it. Next is I am loading the data set. How I am loading the data set is my data set is a CSV file, so I am using pd.readcsv to read that file. I am going to assign that to a variable called df. Next, I'm going to print df.head. This df.head will give you the top 5 values of our dataset. The dataset is stored in F, so I'm using df.head. It will give me the top 5 values. Next, if I use df.tail, it will give me the bottom 5 values. So if I want to check the total number of rows, then I can use len method and pass the variable df. It will give me the total length of our data set. The total length is 1000. Next, if I have to check what are all the data types in our data set, then I can use df.dtypes. This will give me the data types of each variable. Next, if I want to check what are all the columns present in it, I can use df.columns. This will give me the names of the columns that are present in our dataset. Next is suppose you want to check what are all the missing values or which variables are having missing values. Then you can use isNA, df.isNA and dot sum. This will give you how much missing values are there in each columns. So in our data set there are no missing values, so it is giving 0 as values. Suppose if there are any missing values, it will represent the missing values count here. Next is df.describe. df.describe will give you the data like count, mean, standard deviation, minimum, 25th percentile, 50th percentile, 75th percentile and maximum values. This describe can be applied on number values only. Number values in the sense integer and float. Here we have something called state, which is a string value like California, New York and Florida. It will be having values like that. See, the state is not considered in describe. It has only considered the number values. Next is we have our string called state. This state cannot be passed into our model. So first what we have to do is we have to convert that state into a categorical or to a number format. How we can perform that is df of state is having string values. So I have to convert that. First, what I'm going to do is I'm going to convert that into a category. How I can do that is by using dot as type. I'm going to pass it as category, and I'm going to print the data type of it. First, I will print how the data type is before doing that as dot type. See, here the data type is object for state. Now I'm going to convert it into category and I'm going to check the data type. Now the data type is changed to category. Now I have to convert that category into number values. How I can do that is I can just copy this and I have to use .cat.codes to convert that into categorical data. And now I'm going to print df.head. Now if you see, that state variable is converted into a categorical data. Previously it had New York, California and Florida. Now those New York, California and Florida are converted into numbers 0, 1 and 2. Next is, after doing this, we have to split the data, like passing independent variables to one variable and dependent variable to one variable. Here I am going to create X and I am going to pass all the independent variables to this. df.ilog of, I need all the columns, sorry, all the rows, and I require only the independent variables. Independent variables are nothing but R&D, administration, marketing spend and state. Next, in Y, I'm going to store the dependent variable, which is nothing but our profit. I need all the rows and I require only fourth column. Now I have run it. Next thing I have to do is I have to split the data set into train data and test data. How I can do that is by using train test split function that we have already imported using our library. I'm just creating xtrain, xtest, ytrain, ytest. Now I'm going to use train test split and I'm going to pass this xy and I'm going to split the ratio as 20% for test data. If the test data is 20%, it automatically signifies that train data is 80%. I'm going to run this. Next thing is I have to call my model. My model is linear regression. Here I'm going to store that in lin_regression. And I'm going to call my model linear regression. Now I have stored linear regression in linreg. So hereafter I can use this linreg. Next I'm going to fit my train data and test data to this. Train data and ytrain. Now that I have fit my train data, xtrain and ytrain, my model will learn from this so that if I pass new data, it will start predicting on that. I'm going to fit my data. Now my model has learned from the train data. If I pass the test data to it, it will start predicting on my test data. So I'm giving dot predict and I'm going to pass the test data. So if you see, if I pass the test data, it will start predicting on it, and once it is predicted, we can compare the results with our Y test. It has started predicted. Now I'm going to save this in ypred. How we can calculate the accuracy? Our model has already predicted some values. We want to calculate the accuracy. How we can calculate the accuracy is by considering the actual value with the predicted value. This can be done by using R spread score, which is nothing but R2 score, and I'm going to pass Y test and Y predict. Now it has given me an output of 0.96. What this 0.96 represent is our model has predicted 96% accurately. So we can say our model has predicted in a good way. Suppose it depends on the predictions. If the value is closer to 1, we say it is a better model. If the value is closer to 0, then we say the model has not performed well. All depends on the data that we get. If the data is bad, then we cannot expect the predictions to be good. It all depends on the data that we get. all the data will not be in a structured format. All that we have to do is, first we have to clean the data. Clean the data is nothing but missing value treatment, outlier treatment, then pre-processing. What pre-processing does is, all the variables that we have in this data set will not be a significant variable. So which are all the variables that are insignificant, you have to remove all those variables. Suppose you require some other significant variable to be created, you have to create those variables, then you have to pass that to our data. This is all about the interview questions. Hope this video was useful.